Hi, so in this video we're going to cover multiple different features that are either new in 5.5 or just generally interesting but most people don't know about them. So let's get right into it. The first thing that we're going to cover is converting pure native functions into impure. For example, if I type get actor location, and what I'm going to do also is event tick, add world offset. So what I'm going to do is move this object every tick some distance. And then what we're going to do is get the location of the actor. And I'm going to print, let's do 15 seconds, delay of 1 second. And then let's print the location again. And I'm just going to change the color just so you can see what's happening. And let's put the object in the level. And now let's press play. As you can see, we have two prints. One is minus 780 and then we have minus 495. I'm going to change the color. It's blending a bit too much. But you get something that you expected, which is what is the location of our actor at the starting of the game and then after 1 second. And let me just change this to maybe green. And now what I'm going to do is right click on the get actor location. And now what we have an option for is show execution pins. And what this helps you if you never worked with pure or impure functions, when a function has these execution pins, that basically means that it is an impure function. It's going to store all of data in the output pins as long as they're used. So for example, if I connect this now like this, we're going to get the actor location when the game starts. And now our locations are going to be the same at the time when the game starts and then after 1 second. So let's press play and you can see we get 780 for both of them. So they're exactly same spot. To just explain again, we get actor location, and because this is an impure function, it's gonna store this location, and then after 1 second, it's gonna retrieve that old location. It's not gonna recalculate and recheck the actor location. But if we hide execution pins, we are basically recalculating once here and separately in here, and this is not stored. So a really nice thing about this feature is that before you had no option for native functions to choose if they are pure and impure. So if you create your own function and I put it in here, you can see it is impure and you can easily make it pure. But for native functions, you have no option, and sometimes it's annoying to promote a variable, maybe have more variables than you wanted. You maybe just want to have some delay or something that happens later and maybe activate it in multiple places. So now you have that option and it's pretty nice and convenient. Next thing that I'm going to cover is local variables for macros and their persistence. Let's say we create a macro and we can make it for an actor. I'm going to open it up and let's call it test macro. I'm also going to add our execution pins here. It doesn't matter their names. And I'm also going to output a random integer number. And let's connect it in here. If I select a number, let's say between 0 and whatever this number is, and connect it in here. And now let's delete all of this and let's type test macro. I'm going to also delete the vector and then connect my macro on two different places. Let's compile, save, and now let's press play. You can see how we got two different numbers. They're actually kind of close, but they are different numbers. So how macros work, they're basically kind of copy pasting it here. We get the same thing as if we had something like this, which maybe is not something that we want. Let's say inside of the macro, we also want to do the same thing that we did for our impure function, which is to save the variable at the end. So what you can do in here is inside of your macro is right click, type local integer, and you have a bunch of different local variable types. I'm going to do local integer. And what I'm going to do is right click and type set by reference. And what set by reference does is it takes in a variable and sets its value to something. So we're going to set it to a random integer and I'm going to connect it in here. And now the only thing that we need is to get the local integer and connect it in here. So basically what's happening is we're setting this local integer to some random value. And now let's try to play. We get the same number. So this is going to be every time. What we're basically doing is now that local variable is persistent and it's going to do similar thing as an impure function. And this can be pretty useful. So let me show you an example. Here is one of my projects. And what I'm going to do is click right click and type flow cost. This is one of my custom macros where I can track what is the cost of execution of some nodes. So we have flow cost start and we need flow cost end. And basically the idea is whatever is in between these two nodes is going to be executed and then we can save the difference of time and compare them. So I need to pass whatever time I get from the start and compare it with the end time in here. If we didn't have that local variable to save the value, we would not be able to do this. So what I'm going to do is do, let's say, for loop, and I can do for loop with break because it's a bit more expensive. And let's do 5000. On completed, we are going to check how long it took to do just for loop break. It's empty, but there is still a the cost of execution. So if you go inside, all of this needs to be executed. Let's now compile save, and I need to put this object inside of the level. Let's click play, and we can see on the server it was 102 and also on the client 102 milliseconds. Now that's pretty high for just 5,000 loops, but that's because loops are very unoptimized in the editor. I think in the package game is about 10 times faster, so they're pretty slow here. But you can see what we did is we took the start time, which is we get accurate real time. We save it to the local variable of the float, then pass the float, and we pass the float to the cost end. And then in here, we take the time, we minus it with the end time. In here, just for convenience, we are saving it and then using it in here to do some conversions. So we can do microseconds, milliseconds, and some stuff like that. And also for the color, if you want to do some ranges here. So yeah, pretty interesting. For example, if I do, let's say 50,000, we can go back, press play, and now server took about 1 second and client took also about 1 second to do it. Pretty useful thing to know about macros. Next thing that most people do not know about are blueprint customization options in the editor preferences. If you go to editor preferences and then blueprint editor settings, in here you can customize in a bunch of ways how your blueprints work or look. So you don't necessarily have to go to the marketplace and try to find some plugin that modifies how blueprints look or something similar. You can kind of see what you have in the editor and see if that can help you. Just an example in here, what we could do is maybe add some blueprint categories. Maybe you want to have a standardized list of categories in the blueprints. You could add one in here and name it test 1, 2, 3. Then let's go into our blueprints. And in here, if I go to default and then test 1, 2, 3, we can see we have our category in there. Another thing that I'm kind of experimenting, seeing how it goes, are we can go into the visual style here, are points for arrows. So if I enable that, we can see now in between we have these arrows. Now they do make it look a little bit more messy, but maybe it can be useful for stuff like when you have to do something like this. So do once, maybe we connect it in here. If you have some logic like this, maybe it can help a bit to have actual arrows to show where stuff is connected, make it easier to see. But yeah, you can play around, enable, disable stuff in here and see how it changes your blueprints. They do not have to be exactly how you get them as default. Another a little bit scary but maybe useful option that you can use in blueprints is auto destroy when finished. So if I right click, I can do auto destroy, set auto destroy when finished, which destroys the actor if it thinks there is nothing else to do. So if there is no delays or stuff triggering on it. Right now in here, if I add a sphere, just so you can see our object, I'm also going to move it a bit up. And right now let's do 2-second duration. So I'm going to compile, save and press play. Now we can see the object, but then it disappears because 2 seconds passed and there is nothing else triggering in the object. And if we disable this and there is no delay, our actor gets destroyed right away. So we basically set it as destroy and finished, and then it just destroys itself. So yeah, small thing, but pretty interesting. If you have any objects that just need to do something and then disappear, you can do auto destroy and finished, and then you don't have to deal basically with garbage, but you should be just careful with this. Another thing that you can do for your blueprints is in the class defaults, go to initial lifespan, and if you put anything above 0 in here, then that's how many seconds this object is going to be alive. So you can also use that to set a fixed value where you want this object destroyed. And the last thing we're going to talk about is swapping variables. This is kind of a convenience thing. So if I create 2 variables, if let's say, for example, in my project have this variable and I want to swap it around, usually what you would have to do is select it, delete it, pick a new one, reconnect everything, and then stuff works. But there is now a more convenient way, which is you can just pull a variable and pull it over this variable, and now it just switches. And you can do this also with getters. So if I do this, I can just swap it around. Now, this does not work for functions. So if I go in here and set it to impure, create a new function and try to hover over, you can see how we are just creating a new function. We cannot actually swap it around. So this is exclusive for variables, but it still makes stuff a bit more convenient. So that's about it for this video. Hopefully you enjoyed it, and I'll see you in the next one.